Imagine this. At night, the electricity goes out in your neighborhood. Your neighbors' refrigerators, pumps, and communications shut down. But on your property, you have a reserve of energy that was stored back in summer from ordinary water and excess sunlight. Not a lithium battery costing $10,000 or $15,000. Not a generator that constantly needs fuel, but hydrogen produced when your solar panels were generating more electricity than your home could use. It sounds like a technology from the future, but the principle behind it is almost 200 years old. And the most surprising thing here is not that hydrogen can store energy. The most surprising thing is why residential solar systems still almost always end with an expensive lithium battery. Today, we will examine how sunlight can be converted into gas, stored for months, and then turned back into electricity. I will show you the main advantage of this system, honestly explain its weak point, and tell you why an idea that seems so simple is still not installed in every garage. And stay until the end, because the final detail is exactly what separates real technology from a dangerous experiment. Let's start with a problem that solar panel installers rarely talk about. During the day, the panels often produce more energy than the house can use at that moment. The refrigerator is already running, the battery is charged, and the lights are off. The excess energy either goes into the grid or simply remains unused. A lithium battery solves part of the problem. It charges quickly, returns electricity efficiently, and is ideal for a daily cycle. Charge it during the day and use it at night. But it has limitations. It is expensive. Its capacity decreases over time. Extreme heat and freezing temperatures can reduce its performance. And most importantly, most home batteries are designed for hours or, at most, a few days, not for storing summer sunlight until the middle of winter. And this is where a completely different approach appears. Instead of storing electrons inside a chemical battery, the electricity can be used to split water into hydrogen and oxygen. This process is called electrolysis. A solar panel supplies electricity to an electrolyzer. The water molecule is split apart. Oxygen is routed away separately, while hydrogen is collected and stored in a special vessel. When electricity is needed again, the hydrogen enters a fuel cell, combines with oxygen from the air, and produces an electric current. Water once again becomes the byproduct. So the cycle looks almost unbelievably simple. Sunlight, electricity, water, hydrogen, and then electricity again. But if this sounds like a laboratory theory, here is the first twist. The fuel cell appeared long before modern lithium batteries. And in the 20th century, hydrogen fuel cells were used in space programs because they could produce electricity and water at the same time. The technology was trusted in places where a power source failure was unacceptable. This creates a strange picture. The chemistry has been known for almost 200 years. The principle has been proven. Industrial electrolyzers and fuel cells exist. These systems are already operating that store summer solar energy as hydrogen and return it in winter. So why has this technology not replaced residential lithium batteries? The answer is not as simple as it may seem. First, we need to examine 3 objections that occur to almost everyone. First, hydrogen is dangerous. Yes, hydrogen ignites easily, and storing any gas under pressure must be taken seriously. But the danger depends not only on the substance itself, but also on how the system is designed. Gasoline, natural gas, and propane are also flammable. Yet we use them every day because of standards, ventilation, valves, and certified equipment. Hydrogen has one special characteristic. It is much lighter than air and rises quickly if it leaks. But it is colorless, odorless, and capable of passing through extremely small gaps in connections. That is why an enclosed basement, a random cylinder, and homemade fittings are not a storage system. They are a serious risk. Remember this point, because we will return to it later. The second objection: hydrogen is too inefficient. And here, The critics are right. If electricity is first converted into hydrogen, and then hydrogen is converted back into electricity, some of the energy will be lost. A lithium battery returns a significantly larger share of the electricity it receives. But efficiency is not the only measure. If the solar panels have already produced excess energy that otherwise would not have been used, preserving even part of it may make sense, especially if the energy is needed not this evening but several weeks or months later. 46. Lithium is better suited to daily storage. Hydrogen may be more interesting where a large reserve is needed for a long period. They do not necessarily have to be competitors. Sometimes they are two parts of the same system. The third objection. The equipment is too complex and expensive. The basic principle really is simple, but a complete safe system consists of more than an electrolyzer and a metal cylinder. It requires gas purification and drying, a certified vessel specifically designed for hydrogen, leak detectors, ventilation, pressure regulators, safety valves, a fuel cell, and a control system. And this is where a detail that many videos leave out finally becomes clear. A small demonstration unit can be assembled relatively inexpensively, but a safe home system must not be built from a random propane cylinder and parts from the nearest hardware store. The chemistry may be simple, but pressure, air tightness, and fire safety do not become simple. So what is the advantage at all? Hydrogen's main advantage is time. A lithium battery gradually ages even if it is barely used. Hydrogen in a properly designed sealed system can wait. A week, a month, an entire season. Imagine a house in a sunny region. In summer, the panels produce excess energy every day. The battery is already fully charged by noon, and almost everything generated after that provides little benefit. A hydrogen system can convert this surplus into a reserve of fuel. Now imagine a northern region. There is little sunlight in winter, but in summer the daylight lasts for a very long time. Here, hydrogen becomes interesting not as an overnight battery, but as a way to carry part of the summer energy into the cold season. And finally, consider a prolonged grid outage. A conventional battery can get you through several hours or one night. But if the emergency lasts for a week, the size of the battery is not the only thing that matters. What matters is the ability to build up a large energy reserve in advance and let it wait until the moment it is truly needed. And now we have reached the main question. Why do solar companies almost never offer systems like these? It is not necessarily because someone banned hydrogen or is hiding a secret technology. The reason is more ordinary. Lithium batteries are already certified, standardized, and understood by installers, banks, insurance companies, and building inspectors. They are easy to include in a ready-made commercial proposal. The manufacturer knows how to provide a warranty. The bank knows how to finance the purchase. The installer knows which documents to prepare. The small residential hydrogen system exists in a different reality. There are fewer ready-made standards, fewer trained specialists, and almost no mass market for it. And something that cannot be installed, insured, and financed quickly rarely appears in advertising. There is also an economic reason. It is easier for a business to sell a standardized product that can be installed by the thousands, serviced, and eventually replaced. A system designed to operate for a long time with few consumable components creates a completely different economic model. But greed alone cannot explain everything. Low overall efficiency, difficult storage, safety requirements, and the high cost of certified equipment are real obstacles. The truth, therefore, lies between two extremes. Hydrogen is not a magical battery for $150, but it is not a fantasy that can simply be dismissed either. It is a real method of long-duration energy storage. It is already used in industry, transportation, energy systems, and some autonomous buildings. Its strength is not maximum efficiency. but the ability to store energy for a long time and in large quantities. Now let's return to the detail that cannot be ignored. If someone decides to explore residential hydrogen storage, they should not begin by buying a cylinder or connecting wires. They should begin by calculating energy consumption, studying local regulations, choosing certified equipment, and consulting a specialist who understands how to work with pressurized hydrogen. Because the goal of energy autonomy is not simply to lower the bill. The goal is to have a system you can trust at the exact moment when everything else has stopped working. Imagine the following emergency. The wind brings down the lines. The entire neighborhood loses power, but your refrigerator keeps running. The pump continues supplying water. The phones keep charging, and the energy supporting the house today was collected several months ago from sunlight and water. That is exactly what makes hydrogen so interesting. Not a promise of free energy, not a myth about perpetual motion, but the ability to take what is being wasted today and preserve it until the day it